Thank you very much for joining Tesco and Ventev for today's webinar. This 30-minute webinar will provide a brief overview of Ventev's newest solutions for deploying high-performance Wi-Fi while maintaining an environment's aesthetic appeal. First, I'd like to introduce our speaker, Mike Perry. Mike is Ventev's product manager in charge of antennas and RF accessories. He is joining us from Ventev's San Antonio office. Please send any questions or comments you have for Mike in chat, and he'll answer them at the end of the webinar. If we run out of time, we'll email the questions and answers to everyone. We'll be live tweeting during the webinar with more information and links about these new products, and we'd love to hear from you. Please use hashtag VentevWebinar. One final note, this webinar is being recorded, and Tesco will email a link to the recorded version to all who have registered within a week or so. Okay, let's get started. Mike?
Well, welcome everybody. Thank you for joining us. I know everybody is busy, but we're really pleased that you carved time out of your day to join us. And Ventev is excited to share some of the interesting solutions we're delivering to the Wi-Fi industry on outdoor-based lighting. So without further ado, let's hop right into this. Before we dive into discussions about some of our outdoor lighting-based solutions, I want to give you a brief overview of Ventev. We like to say that after you choose the radio, choose Ventev for the wireless infrastructure to support our deployment. And we like to say that because we offer a comprehensive ecosystem of products, everything from antennas, omnidirectional, directional, indoor, outdoor, multi-leads, different connectors, you name it, we've got antennas for your deployment. We also design, manufacture, and deliver power systems, enclosures and mounts, cables, RF accessories. Again, we can support just about any RF deployment. So that's Ventev wireless infrastructure. So let's hop into the meat of the topic, which is outdoor lighting-based Wi-Fi solutions. First thing I want to talk about is a movement that we're seeing within the Wi-Fi industry that we call the 3 Cs. And we call it a movement and not a trend because we believe that this movement is here to stay. We think it's a fact of life in the Wi-Fi industry. We think it's only going to grow. So let me explain what we mean by the 3 Cs. It used to be network designers concern themselves with wireless coverage and capacity, and that was the be-all and end-all. We have to provide coverage for users, and we have to provide sufficient capacity for the applications that are in use. We're finding that those 2 Cs, the first 2 Cs, coverage and capacity, are no longer enough for a satisfactory wireless experience. Today, we're getting feedback and requirements from architects, from building owners, and from end users demanding a third C, which is concealment. So the 3 Cs are coverage, capacity, and concealment. We're certain that requirement for networks to deliver on 3 Cs is going to continue into the future. And we're seeing that in corporate campuses, city centers, amusement parks, shopping malls, large public venues. We're seeing it virtually everywhere people congregate, and virtually everywhere where wireless is needed. So Ventev is delivering concealed, aesthetic, and small form factor solutions in a variety of locations for a variety of end users and customers to satisfy the 3 Cs. Now, in a few minutes, I'm going to hop into some case studies that detail some deployments that we've partnered with end users and value-added resellers on. And we're going to talk about some technology. But before we do that, if you find yourself thinking, wow, Ventev's doing some neat stuff, but it's not exactly what I need, don't worry. If you need some help from Ventev, we have the RF engineering capability, the manufacturing capability, the testing capability, the delivery, storage, logistics capability to design products to satisfy your unique solutions. So our engineering team has over 50 years of combined antenna design experience. We've got other team members with power, other team members with enclosure cables, connectors experience, we've got a team behind us that can support you. We've got manufacturing sites both in the United States and internationally. We've got anechoic chambers in every one of our manufacturing sites to test our antennas before they're delivered to market. And we've got an extensive logistics chain to get product where you need it, when you need it. So again, if you think to yourself that they're not doing exactly what I need, don't worry. We've got the capability to support you. All right. So we've had the opportunity now, since we've seen this third C, concealment, come up time and again, to ask ourselves what's driving this requirement for concealment. And as we talk to customers, as we talk to partners, as we talk to end users, we've identified 4 major deployment drivers that's driving that third C, that request for concealment. One, and concealment on outdoor lighting solutions in particular. So one of the drivers is lower deployment costs, because by leveraging existing outdoor lighting fixtures rather than buying dedicated Wi-Fi mounts, our partners are saving money. Another is faster Wi-Fi capability. Without having to go out and procure, install, permit in some cases, and test new infrastructure, the Wi-Fi capability can be delivered faster. Another side benefit, which in some cases is the primary benefit, is reduced visual clutter. More and more, we're hearing that aesthetics is an important part of a Wi-Fi deployment. So by using existing lighting, we're not adding more mounts, and that keeps the visual clutter in an environment down to a minimum. And finally, using and placing Wi-Fi on outdoor lighting fixtures puts the coverage where people need it and where people gather, which is near the light. So those are the 4 deployment drivers that we're seeing time and again, which is driving this requirement for the need for concealment. So next, I want to jump into some case studies and a brief review of some technology, just so you get a sense for how broad-based this demand is, and how often we're seeing it, and really to make the concealment concept concrete for you. So in one deployment, we partnered with a well-known U.S. amusement park and a VAR who was deploying Wi-Fi in that park. The amusement park themselves had very strict look and feel requirements. They stipulated that no Wi-Fi infrastructure could be seen at all. It had to be completely concealed. And of course, that was challenging in and of itself because it was 4 acres. All the outdoor guest walk paths and indoor locations had to be covered by Wi-Fi. The AP count was over 250 APs. The number of users per AP was between 40 and 50 connections per AP. The RSSI had to be a minimum of negative 65, so we had to have good signal coverage everywhere in the park, and the infrastructure couldn't be seen. This park, like many partners that we're working with, really care about aesthetics. So our solution was to deploy Wi-Fi access points and antennas on and near existing outdoor lighting fixtures. The solution we came up with was placing a directional Wi-Fi antenna inside the lighting globes that were sprinkled out the park. Now, what you see on the slide here is not the actual photos of the lighting globe, because we needed to provide a cutaway view so you could understand how we approached placing the Wi-Fi antenna inside the light globe. So it's more just representative so you get an idea of what we did. But these light globes had a lighting element. I believe they were LED lighting elements. They had an internal conduit which contained the power cable that went up to the LEDs, and it was also able to fit in the pigtails for our antennas. So this is a graphic representation of the light globe itself and the actual antenna. The solution we came up with had a unique 6BI radiator and an articulating mount. We downsized it so that it could fit inside the existing light globes. It was completely invisible to anybody in the park. Nobody could see it. And besides that, it permitted 100% of the light cast by the LEDs to be spread out around the light globe. It did not interfere with the lighting in any way. This antenna was a dual band Wi-Fi, 6 dBi, fairly narrow horizontal and vertical beam widths. Dual polarization, 2 horizontal, 2 vertical, so we got good performance in a high clutter environment. And it was rather small. So again, it was invisible to the patrons of the park. They're just happy enjoying a great Wi-Fi experience. One other thing about this antenna is it was designed so that it could articulate from 0 to negative 45 degrees, anywhere in between, so that the beam could be placed exactly where it's needed for the optimal coverage. So that is deployed today at this outdoor amusement park. And just one example of where concealment was a major driver in the Wi-Fi deployment. This next case study, we worked with a VAR and an upscale Southern California shopping mall. The shopping mall, again, had a requirement for total outdoor Wi-Fi coverage so they could at least track the patrons at the mall. And in some cases, they wanted to be able to interact with the patrons at the mall. All of this connectivity and data was being sucked back into a data analytics engine so they could understand customer behavior. So the challenges were strict aesthetics once again. The property management was absolutely inflexible on this. They said the Wi-Fi infrastructure has to be invisible. It cannot be seen. The mall's decor had to remain essentially unchanged. They also had limited funding and a demand for rapid implementation, which made it even more challenging. And they had a requirement to deliver 100% Wi-Fi connectivity at peak shopping time, and that was for several hundred users, each with 2 Wi-Fi capable devices. So a pretty challenging Wi-Fi environment that, oh, by the way, also had to be invisible. So again, as we looked around for how we were going to approach this problem, we came back again to the outdoor lighting fixtures and chose to deploy our Wi-Fi antennas and access points on and near these fixtures. So again, a graphic just to give you an idea of the deployment. For this deployment, we collectively decided that omnidirectional antennas were a better approach to place inside the light globes. So we developed a unique mount that could fit, kind of clamp around the conduit itself. We developed some PCB radiating elements that could be attached to this mount. And of course it had antenna pigtails that fit inside the conduit. And we deployed them inside this shopping mall's light globes. And they're working today. So you can see here a graphic that shows the what we call our omnidirectional light globe antenna. Just like at the amusement park, this particular antenna is completely invisible to the mall patrons. Again, they are oblivious to the fact that there's Wi-Fi antennas in these light globes, and frankly, they don't care. All they want is a great Wi-Fi experience, and we're able to deliver that for them. This antenna, like the previous one, is a dual band Wi-Fi antenna, 6 dBi gain, horizontal beam width 360. It's an omnidirectional antenna. And the antenna dimensions itself, including the printed circuit board radiating elements and the clamp, still fit inside the limited volume of this light globe, approximately 6 feet high by 4 inches wide. So again, another deployment, another demand for concealment, and another solution delivered. The next project that we'll look at is a major international technology company who built a new corporate campus. Their requirement is for their workers and visitors that are on their property to have a seamless work environment, indoor and outdoor, which means continuous wireless connectivity. They want their workers and partners, visitors to their property, to be able to move anywhere they want on the property and to be able to work in a seamless fashion. And of course, that required continuous connectivity. They had another requirement for invisibility. Basically, they said that there could be no wireless infrastructure clutter anywhere in the building or outdoors. So again, we came back to outdoor lighting as being the best possible option for deploying Wi-Fi on their outdoor grounds, which are rather extensive. In this case, we didn't deploy into light globes as we did in the previous two case studies, but this property had light poles and they had light bollards. And I'll explain what bollards are in just a moment if you're not familiar. But the light poles themselves are deployed in various places throughout the property, both in the outdoor open area grounds and also in the parking lot. So what Ventev did in this case is we took one of our standard small form factor Omni antennas, developed an adapter disc which can fit inside a 4-inch outdoor light pole, took the cap off of the top of the light pole, slid our antenna in, drilled some holes to retain it. It's clamped in by set screws holding the adapter disc, and delivered outdoor Wi-Fi coverage and capacity in a concealed manner using their outdoor light poles. This in turn turned their light poles into Wi-Fi hotspots. And again, most people on that property have no idea that those are antennas up on those light poles because they were painted with non-metallic paint. They fit seamlessly with the the outer diameter of the light poles, and they're virtually invisible. This antenna, as I said, is basically our small form factor Omni antenna. It's dual band Omni, 6 dBi, 360-degree horizontal beam width, and it is also small at 6 inches high by 4 inches wide. We found, though, that on this particular property, for this particular customer, the light pole coverage was not sufficient. It didn't provide full coverage for their outdoor grounds. So we had to look at another option for deploying additional APs and antennas. What we settled on was the light bollards that were around a lot of the walking paths on the property. Now, the light bollards that were deployed on this property are concrete, and we developed what we think is a rather innovative mounting solution with antenna solution. Fits up inside the cavity of the bollard's body. That converted each one of the bollards into a Wi-Fi hotspot, and again, it's delivering Wi-Fi connectivity to users on the property, and it's completely invisible. We called this particular antenna a pseudo-Omni. The dimensions of the cavity were such that we couldn't deploy a standard Omni antenna. We had to come up with something that was flatter and more rectangular in shape. So this design uses 4 PCB radiating elements on this mounting platform, each with approximately a little more than 90-degree coverage. So in total, it provides the 360-degree omnidirectional coverage, very similar to a standard omnidirectional antenna. And you can see that the picture in the upper left-hand corner is a picture of the actual antenna itself. So those are 3 case studies describing 4 different technical solutions that Ventev has delivered to various users throughout the United States who had requirement for coverage capacity and this new requirement for concealment. And if we had more time, I could list another 10 case studies where we're working with partners, VARs, architects to deliver concealment along with coverage capacity. Now, one of the questions I always get asked, and it's a common sense question, is, okay, that's wonderful. You're putting antennas on the light pole or the light bollard or the light globe or wherever. Where's the access point going? And what we've discovered in working with partners is that there are several options for placing the access point on or near outdoor lighting. One of which is placing the access point in the lighting fixture itself. In some cases, there's room at the base of a lighting fixture, for example, to place the access point inside the lighting fixture with probably a customized mount. And in that way, you get the AP and the antenna very close to each other. Obviously, the AP is protected from the environment inside the lighting fixture itself. That's one way to do it. Sometimes, however, the lighting fixture itself does not have sufficient room to store the access point, in which case you're looking at probably enclosing the access point in an enclosure. The options there are numerous. Ventev has a NEMA-rated line of enclosures that can be placed above ground near the lighting fixture and antenna. It protects and conceals the access point. We've seen these enclosures placed very near the lighting fixture itself, or a little distance from the lighting fixture in shrubbery or other ground cover. We've also seen the enclosures painted with non-metallic paint for an additional level of concealment. So there's another option for placing an access point near a lighting fixture and protecting the access point. One of the more interesting but increasingly common deployment methods we're seeing is burying the access point, and in some cases, if required, a companion switch. Ventev doesn't advocate or approve of any particular approach to burying access points, but we did want to share with the group here at least one way we've seen it done. You can see here on the picture that a VAR and the end user decided to go with the buried access point and switch. So they basically decided where they wanted to put the lighting fixture itself, and then dug out the area around it. Went out and bought some waterproof Duraboxes, connected them up with conduit, and they're out there operating today. So one of the Duraboxes holds the switch, which of course conveys digital data back and forth to the access point, and also provides the PoE plus power that powers the access point. Very near the switch box is the access point box, and then conduit taking the antenna coaxial cables from the antenna into the access point itself. There was a lot of concern when our partners embarked on this buried access point approach about the ability for the access point and the switch to withstand heat buildup, and our partners, by all appearances, have been able to work around that and deploy a solution that is not negatively impacted by heat buildup. So we just wanted to make you aware that we're fully aware that access points have to be placed on or near the lighting structures themselves, and we wanted to share a couple of ways we've seen partners deploy the access points and protect them while deploying. Something that we also have encountered quite a bit recently is while we're looking at lighting fixtures for deployments of Wi-Fi equipment, we also find the need sometimes for power solutions. So we've developed a line of power extenders that overcome a deficiency of delivering power to light poles. A lot of light poles only receive power after sunset, so they don't have 24/7 power. And that's a problem if you're going to place a Wi-Fi access point, for example, on or near a light pole, or any other kind of PoE-powered device, such as security cameras. So Ventev has developed this power extender, as I said, which enables PoE devices to be placed on light poles and lighting fixtures in the optimal target area and be powered 24 hours a day. A couple of examples of deployments we've done with this power extender. One is a California hospital that wanted to extend coverage of their Wi-Fi network, their Cisco Wi-Fi network, so that staff who has the Cisco Wi-Fi phones could be contacted in case of emergency. The solution was to place Ventev's power extender on the outdoor light poles to extend the Wi-Fi network. In another application, a Texas school system with 5 campuses wanted to have PoE cameras deployed in their parking lots so they could create an Aruba-based outdoor mesh network. Again, the light poles didn't have 24-hour power, external power, so they needed the power extender to take the 480 volt AC, increase the number of output ports, expand the size, or deploy a battery bank that could provide power during daylight hours. And 90 of these systems will be deployed across 5 campuses. A little bit more about the power extender. It powers the radio or PoE-powered device for 18 hours from the battery bank and recharges within 6 hours during the night. Delivers 45 watts of PoE, PoE Plus 802.388T power to these PoE Plus devices. The enclosure that the power extender uses is a NEMA 4X enclosure with latch locks to provide protection and security. And there's a seamless power transfer from AC site power when the site's AC power kicks in at night to the battery power and back again. And as I said, provides 18 hours of battery power and 6 hours from AC to provide 24 hours of total power. So that's something else we've encountered a lot when working in and around outdoor lighting fixtures. So just to close and open the floor for questions if there are any, we're seeing a movement within the Wi-Fi industry for coverage, capacity, and concealment. We're working projects today to deliver that capability. And as some of the case studies have demonstrated, we've delivered solutions in the past. We've got a design team and an in-house team that can help you with your unique solutions. And all you have to do is contact us. We're ready to go to work for you. In addition to our concealed lighting solutions, we have unique power solutions that can overcome what a very common shortcoming in outdoor light poles, which is the fact that they don't have power 24 hours a day. So my contact information is here. We're going to follow up with answers to the questions via email, and feel free to contact me anytime. Ventev's here for you, and we're ready to get to work.